Hello and welcome. Today we will be learning trigonometry. So we'll be covering some basic aspects of trigonometry. So let's get started. What we'll find out from today's class is first, let's start from an equilateral triangle. So let's take an equilateral triangle. An equilateral triangle, of course, has equal sides. So if we take an equilateral triangle, let's assume that the sides of this equilateral triangle have the value of 2 units each. So here is 2, 2 and 2. Of course, since it's equilateral triangle, each of the angles will be 60 degrees. So 60, 60, 60. So all the angles are, each of them is 60 degrees to make an equilateral triangle. So now let's assume or imagine a case where we bisect this equilateral triangle from the center. So we'll bisect it. Once we bisect it, we'll have this triangle, which we can take one part of it, one part of the bisection, so we can have this triangle from it. Now, this particular triangle, we have this angle to be 60 degrees. Since we bisected it, here will now be 30 degrees, and the remaining part is 90 degrees. That's right angle. So this is a right-angled triangle. Remember that the value of this side is 2 units. The value of this side is going to be 1 unit now, and the value of this side is unknown. So this is a right-angled triangle. Let's recall that in a right-angled triangle, this side, the longest side, is the hypotenuse. This side is either the opposite or the adjacent. This side also is either the opposite or the adjacent, depending on the angle I am considering. So if I'm considering this angle 60, here becomes my opposite and here is my adjacent. And if I'm considering this angle 30 degrees, then here is my opposite and here is my adjacent. That's how it works. So once we switch the angle of consideration, the opposite changes and the adjacent changes as well. So this is a right angle triangle. Now let's recall some identities or some let's refresh our knowledge on right angle triangle. What we already know about right angle triangle. We know that in a right angle triangle, according to Pythagoras theorem, which we were taught in elementary college or schools, we know that in a right angle triangle, that the square of the hypotenuse is equal to the square of the adjacent plus the square of the opposite. So this is Pythagoras theorem, and it is a very important theorem. So it means that in this right angle triangle, if here is our hypotenuse, this is our adjacent, and this is our opposite, for instance, then square of this side will be equal to the square of this side plus the square of this side. That's what we already know about right angle triangle. But before we solve this specific problem, let's refresh a little, learn a little thing about a right angle triangle. Again, we know that since we know the size of the right angle triangle, there are ratio of these sides. Ratio of these sides. So the ratio of opposite to hypotenuse is called sine. So if the angle is theta, if the angle I'm looking for in question is theta, then sine of that, the sine of that theta is opposite over hypotenuse. Then if the ratio of adjacent to hypotenuse is called the cos, right? So adjacent to hypotenuse is called cosine, that is cosine theta, right? If theta is the angle we are looking for, it can be x, it can be any letter. So the cosine of that angle is adjacent to the hypotenuse. And then the ratio of opposite to adjacent is also called the tan, the tangent of the theta. So opposite to adjacent. We know these ratios already. So a common acronym that we use to remember this is that's a common acronym. So capital, which sin theta is opposite over hypotenuse, cos theta is adjacent over hypotenuse, and then tan theta is opposite over adjacent. That's so capital. Also, there are inverse of these sides. So these sides have their inverse also, and their names. So now the inverse ratio. Since we said that opposite over hypotenuse is cosine, then we can have hypotenuse over opposite. Hypotenuse over opposite. That's the inverse of opposite over hypotenuse. So hypotenuse over opposite is called what? It is called cosec theta. And it is the inverse of sine. That is 1 upon sine theta. That's the cosec theta. The inverse of sine theta. Similarly, the inverse of cos theta, which is now cos theta used to be is originally adjacent over hypotenuse. So if we now have hypotenuse over adjacent, it becomes the secant. That is sec theta, which is inverse of cos theta. Also, the inverse of tan. Tan is originally opposite over adjacent. So if we have adjacent over opposite, adjacent over opposite is called cot. That is cotangent. Cotangent of theta. Instead of opposite over adjacent, which was tangent, now adjacent over opposite is now cot. And theta is inverse of theta. So we need to know these ratios and their inverses. So what we have just established now is that cosec theta is inverse of sin theta, and sin theta is inverse of cos theta. Sec theta is inverse of cos theta. Sec theta is inverse of cos theta, and cos theta on this one is inverse of sec theta. Cot theta is inverse of tan theta, and tan theta is inverse of cos theta. So each of them, they are inverse of the other one. So we'll keep this in mind. Also, we know from Pythagoras theorem, let's consider any simple, any regular right angle triangle. So consider this right angle triangle. We know the sides have been identified, and here is angle theta. From Pythagoras theorem, we have that hypotenuse squared is equal to opposite squared plus adjacent squared. That's what Pythagoras theorem told us. Now, mathematically, I can decide to modify this equation. That means I can decide to divide through by any value. So, for instance, let me divide through by hypotenuse squared. So, if I divide through by hypotenuse squared, then this will cancel this. I'll have that what will be left here is 1 is equal to what I'll have here is opposite upon hypotenuse squared plus what I have here is adjacent over hypotenuse squared. But then opposite over hypotenuse is what we have already established and described as sin theta. And adjacent over hypotenuse is what we already know as cos theta. So I can say that 1 is equal to what I have here is now sin squared theta That means because it is squared, that's why I'm having sine squared, right? Plus, what I have here is adjacent over hypotenuse, so, and the square, so that is going to be cosine squared theta. So what I just established is a very important trigonometrical relationship, that sine squared theta plus cos squared theta will give me 1. This is very important relationship. So we are going to keep this in mind. Remembering Pythagoras theorem, we'll keep that in mind also, and keep this one in mind. Very, very important. Okay, we can still make other modifications to this particular relationship. You can decide to divide through by opposite squared. You can decide to divide through by adjacent squared. Let's do that and see what we get. So, from Pythagoras theorem, I'll now have that hypotenuse squared is equal to opposite squared plus adjacent squared. If I decide to divide through by opposite squared, I'll now have that what I have here is going to be opposite squared over opposite squared over opposite squared. So this becomes hypotenuse over opposite all squared is equal to what I have here. This cancels with 1 plus adjacent over opposite. It is still here we have adjacent over opposite all squared. So remember what we called hypotenuse over opposite is the inverse of a sine. So this means that this is going to be cosec squared theta is equal to 1 plus adjacent over opposite is going to be the inverse of tan, which is cot squared theta. So another relationship we have seen is that cosec squared theta is equal to 1 plus cot squared theta. So we can keep this in mind also. It's very important. Then we still go ahead. We can do similar modifications. Remembering that hypotenuse squared is equal to opposite squared plus adjacent squared. So again, we divide through by adjacent squared. So when we divide, we are having that this is adjacent squared over adjacent squared over adjacent squared. So hypotenuse over adjacent is secant, that is the inverse of cos. So this is going to be sec squared theta is equal to opposite over adjacent is sine. So this is going to be opposite over adjacent is tan. So this is going to be tan squared theta. And then adjacent will cancel adjacent. This will give us plus 1. So we have that sec squared theta is equal to tan squared theta plus 1. Another important relationship. We can rearrange these relationships to make any of them the subject, and then we use it and apply it anywhere we want. We just have to keep it in mind. Okay, so these are some important relationships. Let's derive one last important relationship before we go ahead and solve the problem we are faced or want to solve. Remember from Pythagoras theorem again, or from our basic trigonometry, that sine theta is opposite over hypotenuse, and then cos theta is adjacent over hypotenuse. So let's find the ratio of sine theta to cos theta. So if we have sine theta over cos theta, it's going to be opposite over hypotenuse divided by divided by adjacent over hypotenuse. Of course, you know that this thing means by these divisions, we have that this is going to be opposite over hypotenuse times, we change this to times, and we have that this is hypotenuse over adjacent. So hypotenuse can cancel hypotenuse. Remember that this is sine theta over cos theta. So cancel this, and we are having that sine theta over cos theta is going to be, what is left here is opposite over adjacent, right? Opposite over adjacent. And remember what we call opposite over adjacent. Opposite over adjacent is called what? Tan theta. So what we just established is that sin theta over cos theta is tan theta. Sin theta over cos theta is tan theta. And when we turn it upside down to have cos theta over sin theta, then this guy will turn upside down to become cos theta. So this is another important relationship. So enough of these few relationships. There are so many trigonometrical relationships that we can establish, and this is just our first class on trigonometry. When we go further, we can when we leave the basic aspects of trigonometry, we go to compound angles and derive all the equations that are necessary there. But for now, let's just focus on the primary aspects and enjoy what we have. So returning to our question, our original problems, let's go ahead. Remember, we know this side to be 2, we know this side to be 1, but we don't know this side. So we can call this side side x, right? Going by Pythagoras theorem, we'll find the value of this side x. So how do we do that? We just go ahead and say that 2 squared is equal to x squared plus 1 squared, right? This is 4 is equal to x squared plus 1. Collecting like that, we have that x squared is equal to 4 minus 1. So x squared is equal to 3. We now take the root of both sides, and then we have that x is equal to 3. So that's the value of this side, square root of 3. Now what are we going to do with this whole relationship that we have just found, or values? So we have that here is now root 3. Let's go ahead and then use this triangle to find the trigonometrical values for the special angles, angle 30, angle 60. We are still going to do for 45, and then we'll summarize the special angles before we go ahead and solve problems with what we have learned so far. So now, considering this our triangle, we have found the value of the 3 sides. So let's go ahead. This side, if we are considering angle 30 degrees, this side, this with 3 side, is the adjacent. So let's put it down so that you will not mistake it. This side is adjacent for now. When we are considering that, this side that has the value of 1 is the opposite, and this side that has the value of 2 is the hypotenuse. So let's not misplace the sides. Now let's find the value of our angle 30 degrees. So remember, in this case, our theta is equal to 30 degrees, right? So sine theta, remember, sine theta is opposite over hypotenuse. In which case, what we have, our opposite is this side 1, and then hypotenuse is this side 2. So it means that sine 30 is going to be 1 upon 2. That's the value. If you press your calculator or you check your 4-figure table for sine 30, you are going to get 0.5. And that 0.5 is exactly 1 over 2, right? So then that's the value of sine 30. Let's go ahead and do for cos and tan. So in this case now, we are looking for cos theta. Cos theta, remember, is adjacent over hypotenuse. And our adjacent, in this case, we are calling for sine 30, cos 30. Our adjacent is root 3, right? Root 3. And then our hypotenuse is 2. So cos 30 is root 3 upon 2. If you punch root 3 upon 2 in your calculator, you are going to get 0.8660, and it continues. Now, and if you punch cos 30 in your calculator, you still get 0.8660. Make sure that your angle is measured in degrees. Your calculator is placed in degrees for you to get the accurate value. So these angles are measured in degrees. So 30 is going to be cos 30 is root 3 over 2, which is the same thing as 0.8660. That's what your calculator will give you. So these values you are getting are the values you use in your exams when you don't have calculators around, or when you don't want to make use of calculators. These angles are special angles. So let's solve for tan. Tan theta is equal to, the formula for tan theta is adjacent, or opposite over adjacent, right? So in this case, we are talking about tan 30. Tan 30 degrees, our 30 is still the same. Our opposite is 1. Our adjacent is root 3. So we have 1 upon root 3. That's tan 30. Now, because this is odd, an irrational number, we will try to rationalize it. How do we rationalize? We multiply. So, but this is the answer, this is the value for tan 30. Point to your calculator to confirm the value also. But we can rationalize it and write it in a different way. So to rationalize, we rationalize with root 3. So we are multiplying both sides by root 3 or root 3. We are multiplying both numerator and denominator. So this is going to be 1 times root 3 is going to be root 3, and root 3 times root 3 is going to be 3. So tan 30 is certain as root 3 upon 3. So we can write the value of tan 30 as either we write it as 1 upon root 3, or we write it as root 3 upon 3. Any of these can serve. They are all giving the same value. So any of them can serve. 1 upon root 3 or root 3 upon 3 for tan 30. We need to memorize these values. So let's now go to angle 60 degrees and straight up. In this case, our theta is 60 degrees. So let's start again from sine 60. Remember that sine theta is opposite over hypotenuse. Now, once we are talking about 60, these sides will change. And we now have, okay, hypotenuse is permanent, it doesn't change. But since we are talking about 60, our opposite becomes root 3. So our opposite is now root 3. Here becomes opposite, and here becomes adjacent. So sine 60 opposite over hypotenuse. Our opposite now is root 3. Then hypotenuse is 2. So sine 60 is root 3 upon 2. Similarly, we'll talk about cos 60. Cos is now adjacent over hypotenuse. Our new adjacent is 1. So we are going to have 1 upon our hypotenuse is 2. So cos 60 is 1 upon 2. Confirm these values from your calculator. Punch them and know if these values correspond with the values you get from your calculator. Punch root 3 upon 2, know the value, and then check in your calculator cos 60. Know if it will give you exactly the same value. Okay, so this corresponds. Then we'll talk about tan. Tan 60 is, we have opposite. The tan is opposite over adjacent. Our opposite is root 3 over adjacent is 1. So root 3 upon 1 is something as root 3. So what we have just found now are values of sine 60, cos 60, and then tan 60. Remember, if you are writing any external exam, especially Jamb exam, you are going to need to memorize this value. Both for your physics or your mathematics exam, you will need it, and even chemistry. So now let's go over to angles 45 degrees, which is another special angle. We are going to bring a new triangle for that. You can see that there is no 45 here. 45 degrees, consider a right angle isosceles triangle. This right angle isosceles triangle, it means the two sides are equal, that's the isosceles. So the two sides are 1 units each. For instance, we can use any value, but we prefer the 1 unit for easy usage. Now the remaining angle is 90 degrees. Since it's isosceles, these two angles will be equal, so each of them is 45 degrees. So let's find the value of this missing side. We don't know the value of this longest side, the hypotenuse in this case. We can call it y. Let's find the value of y. Still employing the Pythagoras theorem, we have that y squared is equal to this side squared, that is 1 squared plus 1 squared. So that y squared is equal to 1 plus 1, right? Y squared is 2. We take the root of y squared, and we have that y is equal to root 2. So this unknown side, we have the value of